JavaScript is what makes the web interactive. In this video you will learn the core fundamentals you need to start writing your own code. If you don't understand something right away, don't worry, deep understanding comes through practice anyway. Of course, if you watch the video until the end, things will become much clearer. Add JavaScript to an HTML file, you need to use script tags. Using console log, we will display the variables content like this. For better structure, it's best to place your code in a separate script.js file and link it to your index.html like this. Let's start with variables. In JavaScript, variables can be declared in 4 ways. The modern way is to use the keywords let and const, while the older, non-recommended ways are using the keywords var or automatic declaration. We declare a variable using a keyword and a name, then use the equal sign to assign it a value, such as a number or a string, and we use console log. In this image, you will see the rules you need to follow when creating variables. Now, a value can have different data types. For example, the value 6 is a number, hello is a string, and true is a boolean. Don't worry about memorizing the technical definition of data types. It just describes what a value is, which tells JavaScript how to handle it. For instance, 6 plus 4 equals 10. But another 6 plus 4 results in 64 because the quotation marks tell JavaScript to treat the numbers as text string. With numbers, we can perform addition, subtraction, and the various other math operators you see on the screen. While the previous ones were arithmetic operators, we will now move on the comparison operators. Here are some examples of what comparison operators are. For example, is 7 greater than 5 or is 7 equal to 7? Comparison operators always return either true or false, so the result is a boolean. Now let's move directly to logical operators. These are used to combine multiple conditions. For example, AND means both conditions must be true. The OR operator means at least one condition must be true. Finally, the exclamation mark represents not. It flips true to false and false to true. Don't worry if this sounds abstract for now, it will make more sense once you use it inside actual code. Next, we are going to introduce control flow and practice using operators through if-else statements. Imagine you are writing the logic for an electronic gate at a club. The gate needs to decide whether to open or stay locked based on a person's age. First, we store the person's age in a variable. In this case, the person is 22 years old. The gate asks a question: is the age greater than or equal to 21? Since 22 is greater than 21, the answer is true. Because the answer was true, the computer runs the code inside the first set of curly braces. It prints, "You can enter," and the gate opens. If the person were 19, the question will be false. The computer will skip the first block and jump straight to the else block, printing "too young." Now they need to be old enough and have a ticket. Both must be true. Now the security guard has a stricter rule. Age is not enough. You also need a ticket. We have two variables, age and has ticket. For the gate to open, both must satisfy the rules. The AND operator acts as a bridge. It tells the computer, check the age and check the ticket. Is age true and is ticket true, since both sides are true, the all condition is true. The computer enters if block and prints "welcome in." If even one of these was false, it will jump straight to access the need. What if they don't have a ticket, but they are a VIP? If either is true, they get in. In this example, we have added a fast-track rule. To enter, you must be an adult and have either a ticket or VIP status. Finally, we check the club capacity. Sometimes it's easier to check if a condition is not true. The exclamation mark is the logical inverter. It flips true to false and false to true. The variable is full is false. Here, our variable is true because it's inverted using the exclamation mark. Because the condition evaluates to true, the computer prints we have space common in. Let's talk about loops. We use loops when we want to repeat an action without writing the same code over and over. A for loop is perfect when you know the exact number of repetition. Imagine a fitness trainer counting 5 push-ups. We start at 1, check if it's 5, and after every push-up we add 1 to our count. It's clean, fast and efficient. Now let's look at the while loop. Unlike the for loop, we use this when we don't know exactly how many times we need to repeat an action. Think of it like feeding a hungry toddler. We don't know if they will be full after 2 bites or after 5 bites. So, we tell the computer, while the child is hungry, keep providing food. In this code, the loop checks the isHungry variable. As long as it is true, it keeps running. Inside the loop, we count the bytes. Once we reach 3 bytes, we change isHungry to false. At that exact moment, the loop stops. It's the perfect tool for situations that depend on a condition rather than a fixed number. Next, let's talk about functions. Think of a function as a reusable machine. Instead of write the same code every time a new guest arrives, we build a machine that does the job for us. In this example, we define a function called greetGuest. Inside the parentheses, we have a parameter called name. This is like a placeholder. When we call the function later with a real name like Alice or Bob, the machine takes the name and plugs it into our message. Functions are the building blocks of professional code because they allow you to write once and use them everywhere. It keeps your project organized and saves you from repeating yourself. Now we're going to talk about the return keyword. First, we define our function machine. It's called addNumbers and it has 2 empty slots, or parameters, which we'll call num1 and num2. Here is the important part. Instead of just printing the result, we use return. This tells the function to finish the math and hand the final answer back to us. Now we call the function with the numbers 6 and 7. Because the function returns a value, we catch it and save it inside a new variable called result. Finally, we print our variable. Since the function successfully handed back the number 13, this is exactly what we see in the console. Now let's move on to arrays. An array is used to store multiple values in a single variable. For example, if I want to store a list of numbers or names, I can put them all into one array. Arrays use square brackets, and the values are separated by commas. Each item inside an array has a specific position called an index. In programming, array positions start at 0. If we want to select a single element, we do so by choosing its index. Now let's talk about objects. Imagine you are building a video game. You have a player, and that player has different characteristics like a name, a score and a level. Instead of creating 3 separate variables, we group them into one single object. An object is like a container that holds related information. We use curly braces to define it. Inside we have key values pairs. For example, name is the key and Alex is the value. To get information out of an object, we use dot notation. We simply write the name of the object, a dot, and then the property we want, like player.name. It's like saying, go to the player object and find the name. Objects make our code much easier to read. Instead of just having random numbers and strings, we know exactly what each value represents because it has a label. Now let's look at for each. This is built-in method specifically for arrays. It's a more elegant way to iterate through your data. Instead of managing a counter variable like I, we just call the method directly on our array. This code goes through the list of friends one by one and says hello to each of them. Before we can change anything, JavaScript needs to find the element. We use document query selector. Think of this like a search warrant. We are telling the browser, go into the document and find the element with the ID main title and the one called magic button. Now we want something to happen when we interact with the page. After select the elements, we can interact with them. We add an event listener to the button element. This is like a security guard waiting for a specific event. In this case, a click. The code inside this function will stay asleep until the button is actually pressed. Once the button is clicked, the magic happens. We access the text content property of our title object to change the words on the screen. We can even reach into the CSS using style color to change color to blue. Notice that we didn't change the HTML file itself. We changed the DOM, which is the live version of the page running in your browser. The DOM turns your static HTML tags into a live object that JavaScript can talk to, listen to, and change at any time. What JavaScript topic should we cover next? Let me know in the comments.